There, finally a student at IT Mandi working in AI/ML, and this is my submission for the Hiring Cafe take-home assignment, an AI job search engine that understands natural language queries and refine over conversation on 100K real USA job posting. To start with it, we first look at the foundation, the database. So this is the offline processing. I streamed the 8.4 GB JSON-L file here. Basically, what I did was to make the cluster using k-mean clustering. I made 150 gig clusters, and then I also extracted the structured field from the v7 that was provided in the JSON-L, considering containing the company data and other metrics. From each 150 clusters, I sampled 100 jobs roughly, and then used Spacey with custom vocab to pull more features from the raw description like skill industries. Now everything is stored in the SQLite, and here we can see the database in itself. And you can see that I also have the cluster ID and the embedded IDX, which will make sense. And next, we can see the diagram to understand it real quick. So what happens is that the user types a natural language query, and the LLM then passes the intent and make the SQL filter for it accordingly. The SQL filter gets to the SQL, which chooses a search and proves our search space basically. Then what happens is that we select the relevant cluster IDX, and from those cluster IDX, we also have a query vector generated in the pre-processing itself, where I generated which query is most relevant to all these jobs. We do semantic, basically cosine similarity between those, and find the most relevant cluster, loads those cluster already made FIS indexes, and then in those cluster we do the vector similarity searches, and we get the top K most relevant jobs. We rank them, and the return the results. So it happens in lower latency. The cost is less because the only task the LLM has to do is to parse the given query into the filter and the intent, and then this is fed, and we can have a conversation flow, which I'll show in the demo. And yeah, so that is how it is happening. So now I will show the demo. I made a Streamlit app to showcase the thing. Now we open it. So this is the dashboard that I built. So let's start with let's say a data scientist position. Okay, so we can see we have many results regarding data scientist positions. Now I want to make it entry level. So to show like the conversation. Also we can see so we had um, the 100Ks, and then it was reduced that how much the latency was, how much token it used, how much the cost was, roughly around $0.0006. And fallback search basically means like when the SQL basically when our LLM parser fails, we fall back to semantically matching with every job, which is time taking. But it's a fallback that I've thought of in the constant time. So it did not use that because the SQL filter did work. Now we do it, make it entry level. So we can see many entry level jobs have been now displayed. So anyways, let's now go towards a complex query. Wait, I had that which I tested before. So let's try this one again. So this basically is a very complex query. If you see, we have different constraints. So let's try it. Okay, so one study team. Now it's a Series B startup or not, we have to check. Is Series B startup. We learn such as yes, is a Series B startup, so did a good job actually. Let's see for um, Victor Labs, because since Victor Labs is a you know, has a job payment given as well, which does come under the category of our search query. So let's see if this one was correct as well. Okay, it is correct. So we can see it also is able to handle the complex queries. It also is able to do the conversational thing. So yeah, I think this summarizes the entire thing which I built. We can see the SQL filtered 207 queries. Then we did a semantic thing and we had 20. Final was 20. Latency fallback was not used. The cost was a bit much because the number of tokens were more, since the big query was a bit huge and complex. So yeah, that summarizes the entire project which I did for the take home assignment.